Assalamu alaikum, dear friends. Today we are going to discuss diffraction. In the previous few lectures, we discussed the interference phenomena. From interference phenomena, we concluded that light has a wave nature. The diffraction phenomena also shows the wave nature of light because the particle move in a straight line. The particles cannot bend after passing through an opening. So first we need to define the diffraction. What is diffraction? The phenomena of bending of light around the edges of an opening is called diffraction. It means whenever a light falls on some obstacle or some object, then after passing through some obstacle or some opening, the light bends toward its shadow. This phenomena is called diffraction. Let's explain this definition with the help of few examples. This figure shows an object of length L and a screen of length 2L and a source of light. Here we see that when the light falls on this object, it will be blocked. In this area, the light falls on the screen and we will see a bright area. Yeah, in other words, we can call it bright fringe on the screen. According to our thinking, the shadow of this object on the screen should be equal to the length of this object, which is equal to L. This shadow, which is equal to L, is called the geometrical shadow. Geometrical shadow means the length from here at this point to this point is called geometrical shadow. According to our thinking, the shadow should be from this point to this point. But when we do experiment in our laboratory, we observe that the shadow of this object is less than the length of this object. It is just because of the bending of light. When the light strike at the corner or at the edge of this object, it bends through its shadow. The original path of this light ray is this one. But after striking with the edge of this object, the light bends towards its shadow. It strikes at this point instead of this point. That's why the shadow of this object is less than the length of this object. So the shadow will be from this point to this point, and we will get the bright area from this point to this point. So in this situation, the bright area is larger than the shadow of this object. This phenomena is called a diffraction of light. Similarly, if we make an opening in any object and place between the screen and source of light as shown in this figure. In this figure, this one is the object which has a small opening, or we can call it a hole, and this is the source of light and this is the screen. So when the light rays pass on this object, here at this area the light rays will be blocked, and also in this area the light rays will be blocked, and the light rays will pass through this opening. Now, according to our thinking, the bright fringe on the screen should be equal to the length of this opening. Means the bright fringe should be from this position to this position. But when we do experiment in the laboratory, we observe that this bright fringe is larger than the opening in this object. This is because at this position, when the light strike at the corner of this object, it bends toward its shadow. The original path of this light ray is this one. According to our thinking, it should be strike at this position. Also, at this corner of the object, the light ray bends like this, and the original path of this light ray is this one. So, the width of this fringe is larger than this opening because the light rays bend towards its shadow, or we can say the light rays bends around the corner of the opening or an obstacle. So the bright fringe is greater in length than this opening. This is called the diffraction of light. This example is very similar to a small window in our room. The light coming from the sun through window shines our whole room due to diffraction. Now we want to take example of water droplets in clouds. This figure shows water droplets in clouds. These tiny water droplets found in the clouds are called atmospheric particles. If we take few drops of water droplets in clouds as shown in this figure, the light coming from the sun will diffract. For example, this is the water droplet, and here is a source of light, and this one is the small gap between the water droplets. When the light comes from the source of light, after passing through the corner of this droplet, the light rays bends toward its shadow as shown in this figure. So the light ray after passing from this water droplet through these small gaps diffracts in different directions, and after passing this droplet the light well appears brighter when there is constructive interference and appears darker when there is destructive interference. The diffraction of light depends on the wavelength of light. The wavelength of light must be comparable to the opening through which the light is passing. I would like to take a very simple example of wire and object. In this figure, we have an object of some length and wire. The length of this wire is smaller than the length of this object. So, in this case, we are not able to bend this wire around the corner of this object because the length of this wire is very small than the length of this object. So, we cannot bend this wire across the corner of this object. But here in this case, the length of wire is greater than the length of this object. So, we can easily bend this wire across the corner of this object as shown in this figure. In this figure, the wire is bent across the corner of this object. This example is very similar to light waves and sound waves. Here in this figure, we see that there are two persons standing on the two opposite sides of wall. This person is standing on one side of the wall and this person is standing on other side of the wall. So when this person switch on a torch, the light rays will move in straight line. It will bend less because the light has a very small wavelength. So it will bend, but the bending is very small. As shown in this figure, this is the light coming from the torch or hair. So this person is not able to see this person because the light moves in this direction. It cannot reach to this person. So this person is not able to see this person because the wavelength of light is small. But here in this case, we have also the same two persons standing on the sides of the wall. If this person is talking, then the sound of this person will spread around the corner of this wall. So this person standing on the other side of the wall can easily hear the sound of this person. It is because the wavelength of sound is greater comparable to the edges of the wall. So it can easily diffract across the corner of this wall. That's why in our daily life, if someone is talking on the other side of the wall, a person standing on the second side of the wall can easily hear the sound of the person. But the light falls on the corner bends very less as compared to the bending of sound. It is because due to the difference of wavelength. The wavelength of light is very small as compared to the wavelength of sound. So this phenomena is called diffraction of light. In the next lecture, we will discuss the types of diffraction. This is something about the diffraction of light. Thank you.